Okay, today we're going to start our lesson on the law of signs in the ambiguous case. This happens when we have a side-side angle situation, and that's the only time that might happen. There are a couple of possibilities. First one here, if angle A is obtuse, you have two possibilities of either no triangle or one triangle. If side A is shorter than side B, then the answer is no triangle. You're going to set up all your triangles with the angle given on this corner here, the side across over here, and then the third side is always going to be sitting over here for us to work these problems when you're setting them up. If A is longer than B, then you have one triangle. It gets a little bit more complicated if A is acute. For these kind of problems, the first thing you need to do is find the height of each of the triangles. And we're going to want to look at them, kind of seeing how the height and the two sides compare. If A is shorter than the height, we have no triangle. If A is either the same or a little bit bigger, but smaller than B, we have one triangle. And if the numbers get bigger going counterclockwise, height, then side A, then side B, then we have a case of two triangles, and I'll show you how to solve for that. So let's look at some examples here. Okay, so here we've got a triangle. The first thing we want to do is find the height. You're going to use that using our SOHCAHTOA methods. It's been figured out for you here as 3.9, but remember what we have is a right triangle if you drop the height. We're looking at this angle. The height's going to be the opposite over the hypotenuse, so just to be sure, the sine of 51 is equal to the height over 5. Then when you solve that, we did find it to be 3.9. Notice that here that A is shorter than the height. So if we were to drop this side down to try to create a triangle, what's going to happen is it's going to come down, it's going to just start swinging here. It's just not long enough. So the answer to this particular problem is no triangle, and that's what you're going to give us here in these boxes for the answers. Problem number 2 is showing what happens if we have a situation where we might have two particular triangles. Again, when we're setting this up, we want the angle over here in that bottom left corner, the side across, and then I want you to put that third side over here. So the first thing I'm going to do is find the height. So I want to find the height of the triangle here. So I'm going to say the sine of 40 is equal to the height over 16. And when we go through there, we find that the height is about 10.3. And notice that the numbers going around this way are getting bigger. 10.3, then 13, then 16. That is an indication that we have two triangles here. So first thing I'm going to do is fill in the information that's given. I was given that angle A is 40 degrees, side A is 13, side B is 16. Those numbers are set for both of the two triangles. You're going to put triangle number 1 on this side, triangle number 2 over on this side over here. So we're just going to go ahead. We're going to start using our law of sines, start figuring things out. You need to find this angle over here first. So I'm going to say the sine of B over 16 is equal to the sine of 40 over 13. These are we have to use this side here because that's the only ones that we have that we know are given. You're going to need to use your inverse sine figures here to figure this out. So B is going to be the inverse sine of, let's see, 16 times the sine of 40 over 13. And when I put all that into the calculator, remember to put it on degrees, we get B to be about 52.3. All right, so that would be triangle number 1, 52.3. Triangle number 2 comes around if this side 13 over here was able to swing inward like this. What you do, you get like an isosceles triangle here. So these two angles would be congruent, but what we're looking for is this angle over here. And we find that because it's a linear pair sitting here, we're going to subtract from 180. So to find the other triangle, it's going to be 180 minus the 52.3, and that gets us to 127.3. 0.7. You're going to put or. Now remember, we're building two triangles here. All triangles now, we're going to find angle C here. Remember that all triangles sum to be 180 degrees. So in triangle number 1, we have one angle that's 40, one angle that's 52.3. And when we subtract that from 180, we get 87.7. For triangle number 2, the two angles that are sitting there, angle A40, which is given, we found the other one to be 127.7. We subtract these two from 180, and we get 12.3. The last thing we need to do is find side C over here. In order to do that, we're just going to use the law of sines. We're going to use this angle for triangle 1. So we're going to say the sine of 87.7 over C is equal to the sine of 40 over 13. And when we do that, we find C here to be 20.2. And then we need to see what it might be for the second triangle. So now we're going to say the sine of 12.3 over C is equal to the sine of 40 over, what was that again, 13? And in this case, C turns out to be about 4.3. And that's the way we figure it out if we have the two triangles. All right, let's go to the next page. Let's look at a couple of other examples of situations that we might run into. A lot of the times, we're going to ask you to draw the triangle. Again, I always want the angle in this bottom left corner here. It's obtuse, so I'm going to draw it as an obtuse. That's angle A at 122. Side A is across at 8. And we're always going to put that third side over here. For an obtuse triangle, we do not need to figure out the height. We just need to kind of look at these two sides. Since 8 is smaller than 12, when I try to close down the triangle, it's also going to kind of just be dangling there. So for here, we have no triangle. Okay, so let's move on to this problem here. Now I've got myself an acute angle, so I'm going to draw it as an acute. We're always putting our angle A over here at 36. The side across is 9. We always want to put that third side over here, which is 12. So this guy over here is going to be angle B, making this angle C. I want to find the height because that's what I need to compare things. So the height here, using SOHCAHTOA, it's the opposite and the hypotenuse. So the sine of 36 is equal to h over 12. The height in this particular case turns out to be 7.1. And again, I run into this situation where we have two triangles. Looking at the numbers going counterclockwise, they're getting bigger as we go around. So we're going to go ahead, use the law of sines, start to figure out what angle B is going to be. So it's going to be, let's see, the sine of 36 over 9 is going to be the sine of angle B over 12. Again, we need to use those inverse trig functions to find B. So B is going to be the inverse sine, cross multiplying this way, 12 times the sine of 36, divided by 9. And when you put all that into the calculator, I got B to be about 51.6. I forgot to put the information in that was given. So angle A is set at 36 degrees, side A is set at 9, and B is set at 12. Again, this is going to be triangle number 1, triangle number 2. In order to find out what the possible obtuse triangle, because remember 9 could be coming in this way as well as we swing this side around, we're going to subtract this 51.6 from 180. So it's going to be or 180 minus 51.6, and that gives us a total of 128.4. Our next task is to find angle C. So we have one triangle with these two, one potential triangle with these two angles here. 180 minus 36 minus the 51.6 gets us 92.4. The other possible angle C for triangle number 2 would be 180 minus the 36 minus the 128.4, and that would get us 15.6. From there, we just need to figure out what the two potential sides C are. I'm going to use this angle for the first triangle. So the sine of 92.4 over C, and I'm going to use the beginning given information is equal to the sine of 36 over 9. In this particular case, when I do this, I find C to be about 15.3. Or, in the second triangle, if that one is another potential, we're going to use the sine of now 15.6 is equal to the sine of 30, that's over C, sine of 36 over 9. In this case, we find C to be about 4.1. And there are your two potential triangles in the ambiguous case there. I've got two more examples for you. Let's look at number 5. So just scrolling down a little bit. Again, I'm going to draw my triangle. We always put the angle on the bottom left corner. So here's angle A at 50. The side across. And then the third side I always want you to put here for that height to work in that counterclockwise. We have to put this side over here. I'm finding the height. So that's going to be the sine of 50 is equal to h over 4. I find the height to be about 3.1. Because this side's too short, it's going to swing around. In this case, we have no triangle. The last one here at B. Again, that's an obtuse triangle. We got 105. This is angle B. So the side across is going to be 13. You're always going to put the third side over here to the left, always in this piece. I can see 13 is bigger than 6. That means we have one potential triangle. The information I know is that B is 105, side B is 13, and side A is 6. This is just a regular law of science problem. Since this is side A, that's going to make this angle A, the side across, and this guy angle C. So if I want to find the sine of A over 6 is going to equal to the sine of 105 over 13. Again, we need that inverse trig to find an angle. The inverse side, multiplying this way, divided by 13. And when I do that, I find angle A to be about 26.5. And we can put that right in the middle because we know we only have the one triangle. To find the third angle, we subtract 180 minus the 26.5 minus the 105 leaves us with 48.5. And the last step would be to find side C using this angle over here. Oops, we need the sine. Let's try that again. So the sine of 48.5 over C is going to be the sine of 105 over 13. When you put all that into the calculator, you get C to be about 10.1. And that's how we work the ambiguous case. We are no longer going to be doing these word problems here. You can go ahead and cross them off here. You can cross them off in the homework as well. And that is it. Good luck with it.